So you're given a vector v that has certain elements. So say v has three elements. And you're given a vector u that has one less element. So u1, u2, for example. If we were to represent this in a matrix A, and A would be as big as V, we would have V in our diagonal, and we'd have U above that diagonal. Now this will be multiplied by our x values in a matrix multiplication, and will give us another output, which is b1, b2, b3. Now, b1, b2, and b3, this is a vector b that's already given to you. So what our job is to do is solve for these x's. Now, if we were to do that, we're going to work backwards. So we're going to multiply v3 by x of 3 right here, because all the other things right here is 0. So when you multiply by x of 1, it cancels out. X of 2 cancels out. But only thing that's left is v3 times x3 gives us b3. So we have v3 x3 is equal to b3. If you solve for x of 3, you get x of 3 is equal to b3 over v3. Now, here is the thing you have to notice. This digit right here is the last element, all right? This represents actually the size of our matrix. So we'll say equals to n, which is going to be our basically dimension size, or the biggest dimension. Now, if we were to solve for x of 2 right here, we'd say v of 2 multiplied by x of 2 plus u of 2 multiplied by x of 3. That's going to give us b of 2. So if we have right here v2 x2 plus u2 x3 is equal to b of 2. Now if we solve for this for x of 2, we get x of 2 is equal to b of 2 minus u2 x3 all divided by v2. Let me divide. Now if we do the same thing right here where we have v1 multiplied by x1 and u1 multiplied by x2 gives us b1, we get the same thing where we have x of 1 is equal to b of 1 minus u of 1 x of 2 all divided by v1. Now we have to represent this with a function, and we're most likely going to use for loops. To start off, we're going to have function, and our output is y, and our name is backdiag, and our inputs are vectors v, u, and b. Now let's find what the size of v and b is. So we're just going to say n is equal to the length of v. Now once we know what that is, we're going to initialize our basically x of 3 value that we need in this equation right here. Or instead we can say the last element. So we're going to say x of n essentially. So we're going to say x of n is going to equal to now the last element of b divided by the last element of v. So b of n divided by v of n. Now we can actually do this for loop. So if we're going to do this for loop, we're going to go down. We're going down from this number from 3 to 2 to 1. So we're going to say for I is equal to. Now we started at 3. Now we have to start our loop at 2. So at n minus 1, right? Now we're going to go down. So we're going to say colon negative 1 colon 1. We're going to go to the last value. And we're going to write, we're going to say x of I, which is what we want, is going to equal b of I minus u of I multiplied by x of I plus 1, it's the value right above it, all divided by v of I. And then you're going to end your for loop right there, and then you're going to end your, and then you're going to basically just have y set to this output. So you're going to have y is basically set to x, and you're going to end your function. So basically we created a vector x over here that is our answers. Now you could also pre-allocate x right here in order to make this smoother by saying x is equal to zeros, and we'll say n1. So it's a row, it's a column vector, so we want multiple rows in one column. So this will make it go smoother. And then you basically give the last value of x right here. Then you go through your for loop, and in your for loop you're going to have this definition right here in order to basically solve for every single x using backward substitution. and you're going to just give the output y this value, these values of x, and you're going to end the function.